So last week we started a kind of a tour of selected applications of machine learning. Especially, we say machine learning application taking clue from the past successful applications while exploring the present and future possibilities. So we want to put each and one of us in the kind of better contextualization, so that in our video feeds, I know we are from different backgrounds. Civil engineers are there, mechanical engineers are here, computer scientists are there, and so many other feeds. So we want to look at some of the possibilities that we can actually have a look at. So last week we started by taking us through the goal, kind of a brief revision of what is machine learning. Then we discussed the concept of the paradigm shift, so which actually led to the big machine learning concept. That in the past we used to have data and then someone need to write a program, that we are shifting to having data and outputs, and the system will generate the program. That is where machine learning actually comes in. The big paradigm shift actually facilitated everything. And then we spent lots of time on what to remember about ML, the concept of no free lunch. So that machine learnings are algorithms, they are tools. The machine learning algorithms are tools, not dogmas, because dogmas are things that can never be contested. They will remain correct. They remain the way they are actually. You don't question them. And there are very few things like that in this dunya. So, but for machine learning algorithm, they are tools. It means sometimes they can work, sometimes they might not work. And that is where the concept of let the data speak will come in later on. So we also explain the concept that no classifier is inherently better than any other. So, and then we explain in detail why we need to try simple classifiers first. So, and also we explain the concept of better to have smart features and simple classifiers than simple features and smart classifier. Because if your features are not relevant to what you want to model, even the best of classifiers will not be able to do any magic for you. However, if you have carefully selected the features that are very relevant to the area you are trying to model, hopefully, even with a very simple classifier, you can solve the problem. But that doesn't mean simple classifier will always solve the problem, because sometimes we don't have control over the features that we are going to get. Sometimes our clients, they are constrained to a particular feature they got, and those features might not be so relevant, but then this is what they have. We have to help them make use of what they can afford. In that sense, we have to start looking for algorithms that can solve the problem. Simple one might not be able to solve it. So we have to move up to more sophisticated algorithms. Sometimes even you might not be able to find any individualized algorithms that will work for such problem. Then we go for hybrid, or what we call ensemble, whereby we might have to mix together two or more different algorithms. Hopefully, they can collaboratively solve the problem in a better way. So these are some of the stuff we did mention last week. And then we made it clear to ourselves that we should use increasingly powerful classifier with more training data. That is, the more data you have, then you can go to more sophisticated algorithms, because some of the sophisticated algorithms, they need a real huge data. If you don't have enough data, then you might have to confine yourself to very simple one. So today we're going to continue moving further on the applications of machine learning and what we can actually try to think of doing. And I've actually advised us that we should try as much as to keep thinking of what can you do in your area. So hopefully we might stop this talk earlier, so that we want to listen to you actually. So what are you thinking in your area? So try to visualize what are the challenges in your areas that you can try to use machine learning to solve as we move on. So try to contextualize machine learning within the AI big picture and relevant emerging disciplines. So a couple of days ago, I was attending a kind of a presentation. We have selected people who are asked to present, and I noticed that people mention AI. So, and then interchangeably machine learning. What is the relationship between them? So how can we contextualize machine learning within the big name AI? So, because AI has been here for a long time. It's not something new. However, the machine learning aspect of it actually is the one that came and tried to actually change the whole system. When you talk of AI, as you can see, this is the big I, artificial intelligence. It's made up, we have the cognitive aspect, we have the natural language processing. This is the natural language processing, the one that deals with trying to understand what we see, translate our word, try to convert what you are saying to another language. So if I speak in English now, we can make something to convert it to Arabic, to Yoruba, or to any other language. These are called natural language processing. So we have the robotics aspect of it also. So we develop machine that can actually try to do things for us that human beings would ordinarily do. There are different types of robots. Some of them are just flying drones that can deliver weapons here and there. So these are all of them. Then we have the knowledge-based system where we try to extract knowledge from experts. For example, we could extract knowledge from quality control engineers and put it into a knowledge-based system. See, so that that knowledge-based system can be replicated. For example, in your company, you have only 2 quality control experts, and you have branches going to like 20 branches. These 2 guys cannot be in all of your branches. So we sit down, those knowledge experts, we gather their knowledge, we extract information from them, and we use it to build a knowledge-based system. If this happens, this is what you should do. If this happens, this is what you should do. So this is one aspect of AI, which we call the knowledge-based system. So once we build the system, it's usually if most set of rules that have been extracted from the expert, then we can easily distribute this software to different branches of your company. We only need just a system, a computer, so that anybody who can read and write there, maybe an ordinary operator, can try to serve as a kind of quality engineer. So this is one area where artificial intelligence, one aspect of artificial intelligence, and this is also old, actually. It's also old. So in some of the historical background of artificial intelligence, we're not going to go there today. So the idea of machine learning came up a long time ago. However, due to computational limitation, it was neural network idea. It went down because there was no hardware that can support such a system. So it went down, and then people got diverted to knowledge-based system. Knowledge-based system got proliferation because the idea of machine learning couldn't fly at that point in time because the computational complexity could not really be overcome. So these are some of the other aspects of AI that have been in existence, even because machine learning got popularized. Now today, everybody talk about machine learning. Machine learning is just a subfield under AI. We got that one right. So when you hear people talking of AI, okay, which aspect of AI are they using? Now, because AI, like I said, is a big concept on its own. Now here you can see the machine learning contextualization. This is machine learning. Now you can see another small guy here. Under machine learning, we have another special guy here. We call it deep learning. So when you hear deep learning, it's not something totally different. It is just a special aspect of machine learning. Now what makes machine learning unique? There are other aspects of AI. Some people are more interested in robotics, nothing more. Some people are just interested in natural language processing. Like, okay, how can I extract your information from the social media when you chat so the government can know your opinion and host of other stuff. It's been in existence for long, so many big applications. However, today, machine learning is the kind of What makes machine learning to be very, very unique is, apart from the way it works, is that it's almost becoming impossible to develop sophisticated application from any other field without using machine learning. This is the unique aspect of machine learning. That's why machine learning is everywhere. For example, now you can only teach natural language processing. You can only develop natural language processing without trying to make use of machine learning to train your system there. For example, sentiment analysis. Sentiment analysis is under natural language processing. We want to analyze the sentiment of someone. We want to know the opinion of citizens to a particular policy of the government. Instead of the government giving you a kind of questionnaire, and then you are going to be fearing that, oh, if the government knows I'm the one who said this, maybe I'll be in trouble. Okay, no way, nobody will ask you such questionnaire anymore. You just need to go to your social media and see what you are chatting with your friends. Because in most cases, you are going to be very truthful with your friend. So that is sentiment analysis. You want to see your opinion about a particular parastatus and most of other. But all this kind of stuff today can hardly be developed without machine learning. So you see machine learning A. Robotics. We see robotics is a standalone physical structure, either drone. Today, sophisticated robotics, if you want real sophisticated robotics that can really optimize what you want to develop, what you want to deploy, you need to make use of machine learning to strengthen such a robot. See, the same thing goes to knowledge-based system and every other application aspect. So that is why machine learning is more of very, very unique and is standing out among other aspects of artificial intelligence. Because now other aspects of artificial intelligence needs to deploy machine learning also to make their own work to be very successful. Now looking at contextualized machine learning side by side deep learning, like I've mentioned a couple of my lectures. So machine learning is the general one, like the k-nearest neighbor we have explained. It's an algorithm for machine learning, standard machine learning. We also we explain the decision tree. We talk about the naive Bayes and also for others. We're still going to come back later and also talk more, like neural network, support vector machine, and also for others. However, for deep learning, so it's kind of an advanced form of neural network. It kind of expanded the neural network. So, and one of the popular one is known as the CNN, the convolutional neural network, which is a very popular type of deep learning. However, when do we use deep learning? So I'd like to clarify this point. It's not every solution, like we mentioned the other time, that it's always good to start with simple solution, simple algorithm. Don't just go to big algorithm. I've seen lots of people made this mistake. A very simple data set is sent to them. The next thing is they start using deep learning. No, it is wrong. You need to know a kind of course, let the data speak. Yeah, let the data speak. But don't forget, start from simple. Start from simple. Start from simple algorithm. I believe this one is going to assist us a lot. There's the principle of let the data speak. You don't really know which application, which algorithm is going to work for you. That is an established concept. The second is start from simple one. See, because having a very simple problem and then going for deep learning is like you using big hammer, a very big hammer to kill ant on your table. If you're not careful, you break your table and actually the ant might still escape you. Why don't you go for the broom? Very simple equipment for such. See? So when you have a system whereby your data set is very straightforward, you have your data set in column. So let's say, for instance, we have something like this. They give us data set. You have like X1, you have X2, you have X3, very straightforward. These are just numbers. Maybe this is the weight. This could be the weight of the patient. This is the height of the patient, and this is some medical lab result. And then there's targets here given to you that, okay, this one is diabetes, this one is not diabetes. Very straightforward data. It could be in the safety industry. Once the data is very straightforward, you should start, like we said, start from simple algorithm. Start your KNN, start your naive Bayes neural network, and start to trial out. In fact, if things doesn't work out for you, You might start to even talk about ensemble. You might try ensemble, which we also already discussed some times ago. And hybrid options are there for you. Before you finally start thinking of, oh, maybe deep learning can help us. Because deep learning has its own unique characteristics. I want us to know. Number one is that you need a sizable number of samples to be able to think of using deep learning. Your sample should be much, actually. So where you can be having maybe 200, 150, and you are thinking of using neural network, even 25 samples, sometimes k-nearest neighbor, they can still work for you, even lesser. We have had to develop a system using less than 25 samples. They work. However, for deep learning, the strong point that we I often recommend for people is if you have data set that is image-based data set, then deep learning will become a very good option for you to start thinking about, because the advantage is that deep learning has the capability of extracting features directly from your image. Because for other machine learning algorithms, you need to first of all extract the image features. Then when you extract it, you use another software. It could be a third-party software, not part of your machine learning it's not part of your machine learning package. It could be external package that you use to extract your feature from the image. Once the features are extracted, then you need to pass it now to, for example, you want to use KNN. You pass it to KNN. So after you have divided into training and testing, then you can get your model built. However, for deep learning, no, it has that capability. Just supply the image, it will extract the image for you easily. This is one way to see that, to contextualize, you know when to use and when not to go for. Also, when you have videos, then deep learning is a sure bet for you to quickly consider. Because here, instead of manually extracting video images, which you have to do for other machine learning algorithms, so why don't you go for your deep learning? So because deep learning has the capability to extract image from videos directly without any intermediary. So these are the strong points for deep learning. Also, there are some text processing where also you need automated extraction of features. Deep learning also will be very handy and highly recommended for us in this place, because you are going to avoid having to do manual feature extraction, because when you do feature extraction manually, for sure, you could lose some things along the way. Now, also when your data set is huge, when you have very big data set, perhaps it is time for you to start also thinking of go for deep learning as a way to solve this kind of problem. Especially you see the video, it really has a unique capability, because it's very challenging to extract features from your image, from videos. And that's why deep learning is part and parcel of the autonomous driving car. The car that are driving themselves automatically, deep learning is their backbone, because those cars depends on continuous image capturing in form of video. They keep taking videos and images of the environment, and deep learning will be processing it to determine, is it human being crossing the way? Is it not human being? So these are unique applications whereby, for sure, you go for the deep learning. However, when you gather data from clinic, if it is image data, that's good. Videos about patient, maybe in the radiographic center or the radiographic department, radiology department, good, they have a lot of images, we can go for that. However, you gather some very basic medical, the one we call like demographic data, and the laboratory test results. These are basic information. You don't need to bother yourself going to deep learning in this particular scenario. Because we've seen people that went for deep learning for a very simple application, like the example I gave here. They went for deep learning and they were able to get maximum of 74% accuracy. And then with just k-nearest neighbor, already we were able to get like 94% accuracy. Just look at the increments from 74% to 94%. That is the cost of using a wrong algorithm for a wrong problem. So hoping that we take note of this as appropriate. Now, so we can see here that this is where we contextualize machine learning, its position vis-a-vis deep learning. We have explained it a lot. So, and then you can now see another big concept that is crossing themselves here. That is big data. See, let the data speak. So it could be prescriptive application, it could be predictive, and it could be descriptive, depending on the kind of data and the kind of algorithm interdisciplinary that we are bringing in together. Now, now mention a great motivation. So considering some of these things, and especially the fact that machine learning has become actually a kind of a helper to every other aspect of artificial intelligence. These are all standalone special areas of AI. But today, if you want to develop anything unique there that is really superior, you need to bring in machine learning to come and help you there. You need to bring in machine learning to come and help you. So that's why I say a great motivation. That was what was stated by Tony Tita. He said, the director of DARPA, he said machine learning is the next internet. He said machine learning is the next internet. And the meaning is that, as you know, the internet changed the way we do things. So the idea is that another phenomenon that is going to change the way our world looks like, just like the internet did, is going to be machine learning. Just like today, because of internet, the banking operation, everything has changed. The way we communicate, it's internet that made it possible for me and you now to be communicating, even though we are in different continents apart. So imagine there's no internet. So Tony Tita said machine learning is the next internet. That kind of big imagination that you can have. Imagine we don't have internet. What will have been? So that machine learning is the next thing that is expected to change the way we do things. And that is why people that are aware of this fact are already moving at a very fast speed towards that particular reality. That's why some university now already mandatory their system that no matter your department, you need to incorporate machine learning or AI into your system. Because it's either, just like in the discussion I said a few days ago we were in, someone said, well, as a radiologist, you are not going to lose your job. However, the radiologists that refuse to use AI or machine learning might end up losing their job, actually. That is the reality. Yeah. So wherever we are, the earlier we actually try to come on board and see, because as an expert in your area, no one can take your place. We used to have this kind of discussion with our medical doctor friends. People are apprehensive because of the way computer led to people losing their jobs in banking sector. That is the reality. A lot of people lost their job in banking sector because with computers now, you hardly need physical people in the banks. But no, for other professional areas, it cannot be. But we just all need to up our task. We need to get to see how can we use this to improve this kind of a system. For example, like medical doctor now, there are a lot of things they can do, collaboration, to get this system to support them in their work. So, but if somebody says, no, I don't want to use it, then that person might have problem at a point in time because the organization might move and take some policy decision that could affect such person negatively. So this is what, and the fact that every one of us need to realize that the AI or machine learning is not there to stop our job, but then in reality, the rate at which people are going. Of course, personally, I have my own personal opinion on the issue of implementation of AI and machine learning stuff. I still want to believe that people need to respect the job security of people, because there are some automation that are not yet necessary, especially if we want our people to have jobs. So we have to kind of have strike some balance there, because there's some automation that are really going on, so that are going to send away unskilled laborers. Yeah, unskilled laborers. Unskilled laborers can easily lose their job to this artificial intelligence stuff that are coming up. However, for people who are skilled, it's really very challenging. It will be difficult to kick them out of job. But however, they also need to think of how can I make use of this system to improve my own professionalism. This is my personal advice, and this is the reality that is staring us in the face. And the second motivation, apart from this quotation, is the principle of let the data speak, which is what I call the big paradigm shift. So in computing, it is a big paradigm shift in computing. That before we used to think of how we are going to write software, but with machine learning, that is things of the past. And I used to tell my students as AI student, as machine learning student, that look, if anybody is still just writing program, classical, yeah, they are going to be programmer. But things are moving on that you might need to also upskill. Like one of our prof said, you need to upskilling, reskilling, cross-skilling. So we have to bring in a lot of skills to make ourselves relevant in the present day world. So even as a programmer, you need to know how to program for AI, how to write program for machine learning. This is very important because the paradigm shift is saying that instead of just depending on programmer alone, that who is going to write a program and then we're going to supply data and then we get our output, things are changing. Now, data entry class just need to provide us with the data and the output, and with the appropriate algorithm, as I mentioned earlier, we have a program that can always generate what we want for us. And this will be produced without the software writer itself. So the software writer now need to make sure to know that how do we develop this algorithm? So because we still need people who will develop the algorithm, who will program this algorithm, that are making it possible for the machine learning to learn from data and the output provided. So these are reality and the idea of let the data speak, which is going to shift some of the way we think, some of the way we do things, and actually the way we are going to now see machine learning in our own individual fields. So now let us all start thinking inward in our different fields. So what can we do? What are we thinking of doing? And some of the good news is some of these things could actually be made to a startup. Yeah. So some of our colleagues here are aware of that. So whereby people develop even basic machine learning application. Now today, they are startups. They are employing people. So which is some of the reality that is the governments of the world are pushing onto. Not only people, we used to think in the past that the government need to employ everybody, but this is fallacy that they never made people realize. There's no place in the world that government provide job for everybody. It's not possible. It's impossible, by the way. But now we're now in the age of startup. People need to set up their own companies, and for people who are also working, depending on our salary, is another issue entirely. That's another discussion for another day. So we all need to think of, okay, how can I add value to what I know? As a professional, is there any way I can use machine learning to enhance what I'm doing? Hopefully that will increase my popularity and also increase my demand. So time will tell. So moving further, we are going to look at some of the successful application domain by our teams. We're going to give samples of this. So, and then we also look at general application area that we can look into. The list is inexhaustible, by the way. So like, that's why I said, so we expect you also to come up with your own list, some of your own ideas of what we can think of. So let's pick few of some of our earlier areas where we do develop a machine learning application for. The first is the oil and gas reservoir characterization and related predictions. So very popular here is the permeability prediction. So for the sake of those who might not really be aware of that, permeability is trying to measure to determine if there's going to be capability for oil to flow in a well. See, sometimes there could be oil deposit down, but the nature of the sand there, of the earth, does not support extracting oil from that particular place. So in that case, in the past, people need to dig well after they got that, they found out that it's not producing. Alas, they have to abandon it and go to another well. But with technology, they try to say, okay, as the diggings goes on, every meter, you take past sample of the well. You take sample of this particular soil. They have to physically take it to the laboratory, by the way. They will move them to the laboratory. After like few meters, they take sample of the soil to the laboratory. So there, The laboratory will analyze and determine the permeability. Of course, there are very simple attributes they can get from the soil, some signals, see that the gamma ray and some other attributes that they can easily get right there while they are digging. But for permeability, no, you have to go to the laboratory to test it. See, so it takes a lot of time, or you need to set up a makeshift laboratory close to that particular area. It takes a lot of time. The idea now is, can we use the data we have gotten from past years? Since permeability is the most challenging to predict, we have other simple attributes like gamma ray, just send it some signal and you can take the measurement. Okay, give me some of these, see this attribute 1, attribute 2, attribute 3, and then give me some recorded permeability in the past. We call them historical data. We get the historical data, and then can we train our model with enough training set and testing set so that we can predict the permeability? So that while people are digging, instead of having to bring the physical samples to the laboratory and it wastes a lot of time, we can just take those readings, simple reading like gamma ray and other simple and easy to measure attribute on the go, and then we can predict the permeability. If the prediction, if we develop a system with very close prediction to what we've had in the past, then we can rely on it. And I remember the last time we were already getting up to like 97% accuracy, in some cases 99% accuracy in terms of predictive, the accuracy, the correlation coefficient, how close they are to the actual one. And whenever we plot predicted versus the actual, you see a lot of kind of point-to-point matching, which means very close to 100% accuracy. So with this, if you can have this kind of predictive solution, this is going to really make life easy for the people that are dealing with permeability. So after that, we also have what we call the PVT property modeling, also for oil and gas. So whereby also there's need to have such a prediction. Started with very small accuracy, little by little, with more effort, which we are going to explain later, some of the gimmicks. Because sometimes when you start prediction, we want to have very high, for them to be able to rely on the predictive solution, then we want to be able to see that, okay, the accuracy is really very high. So that's why you start with simple algorithm, try to do some things. Then later we are going to share some of the details so that if you face such a thing in your own area of application, you can know some of the areas or some of the kind of application that you can take to get it better. Because we started with simple things like neural network, then gradually we have supervector machine. Because of the nature of the data in that area, they are usually very noisy data. So we graduated to what we call type 1 fuzzy logic. Then later we are even graduated to type 2 fuzzy logic. And then finally we hybridize type 2 with extreme learning machine. These are some of the applications we've used in those areas, and they really produce very accurate and results, depending on the case. So sometimes when you're developing, you have to be patient. It doesn't mean that right away you might be able to get it at once. It could be in stages, because the target is that we want to have the best possible predictive outcome so that our prediction will be closer to the actual values that we had. So if we are able to predict probability to the satisfaction of people based on historical data, then they can rely on it for the next well logging or for the next well digging that is going to be actually carried out, which is very, very important. So if you are very close to this is the actual, and then your prediction can go, not necessarily covering everything. There could be some little error, but if the error is really acceptable, that is fine. So these are some of the areas, one of the foremost areas actually we started with, and alhamdulillah, we're able to achieve a lot of acceptable and really successful performance measures that really necessitated. Then, like I said, also PVT property was also modeled. Later, we look at some of them in detail if necessary. Then thereafter, we move to nanomaterials characterization. So nanomaterial characterization was also done. It's one of the collaborative work with our young Professor Tesli Masafa and Dr. Adeniro. I remember then. So if opportunity comes later in future, we discuss more about how we were able to come into the area of nanomaterial characterization. The magnetic refrigeration alternative energy source also modeling were carried out. And then I think we are going to call it a day at this point to give room for people to ask any question or if anybody wants to contribute. So we are going to call it a day at this point, inshallah. Next time we are going to continue from where we stop for the day. Inshallah, thank you for the time. So, and then wish you all the best. So, thank you.